Yes, it is in a -1 to +1. So again, the skewness is in a range. The kurtosis that minus 0.440. Okay, so again, it is in a range.
Yes, yes, ma'am.
Yes. So how can you interpret this? The mean and median are extremely similar. The values of both mean and median are same. The skewness is 0.049 as shown here in this table, which is well within the acceptable range or -1 to +1. If you want to find out the Z score, I have explained you that how can you find out the Z score. So you have to simply divide this skewness value by its standard. This is the standard error. So you have to divide this value, that is, here I can write 0.49. Sorry. Divide by 0.269. 0.269. So yes, you can calculate, please. Can anyone calculate this? How can you find out the Z score? So you have to simply divide your skewness value, that is 0.049, with the standard. Yes, what is the value?
Ma'am, it's 1.8.
0.182.
Yes, ma'am, 0.18.
Already it will give you 0.182. Now, what is the range of that Z score? The Z score range is plus minus 1.96 to plus 1.96. So what value I get? 0.182. So again, it is in a range of this.
Yeah.
Understood, everyone? Yes. The next value is the kurtosis value. The kurtosis value is minus 0.442, which is well within the again acceptable range. It is -1 to from +1. The Z score, if we calculate, if we divide 442 by 532, then we get the value 0.831. So again, both the kurtosis value as well as this Z score values are again in a range. So you can say that again our data is following some normally distribution. You can say that by this table.
Yes, ma'am.
Normally distributed.
Yes, okay. The next table is the test of the normality. Okay, so the normality test, the Shapiro-Wilk test we are using. Now in hypothesis testing, what we are when we are rejecting the null hypothesis, when our p-value is less than 0.05. But in test of normality, when the value is greater than 0.05, in that case we generally reject the null hypothesis. So in a test of normality, the Shapiro-Wilk value is 0.585. So the p-value of the Shapiro-Wilk test is 585, sorry, which is greater than 0.05. So again, the normality test also show that our data is normally distributed. The next table is histogram table. So by this curve, you can also show that it is in a symmetrical. The curve is again symmetrical. Sometimes the left tail, or sometimes it may be right tail, but here you can say that your histogram is in a symmetrical way. So again, you can say that your data is symmetrical. The next is
Not
the QQ
skewed.
plot. Hello.
Not skewed. The
It is
histogram
a
shows.
symmetrical.
Yes, ma'am. It's symmetrical, right?
Yes, is symmetrical. Now the next is the QQ plot. The QQ plot is something. So whatever the answers of your responder or whatever your data is, so that data should be in a one line. It should be fall in a one line. So here by observing this QQ plot, you can see that your data is in a one line. Understood, everyone? If it falls in this
Yes, ma'am.
region or in this, Yes, if it is fall in this region or this region, then you can say that your data is not normally distributed. But here the data is similar in a one line. Majority of the data are in a one line, except 1, 2. Okay. And the last one, the points do not deviate much from the line in the normal QQ plot, and there are roughly equal numbers of points above and below the line in the different QQ plot. And the next is my box plot. So box plot again, the median is in the middle of the box. You can see here, and the whiskers are of similar length and there are no outliers. What do you mean by outliers?
Noise actually, which is out of range.
Which is out of range. So here we can say this is my variable. This is the questions for which I have tested my. Yes, let me first check. What is your household? Yes, this is the question for which I have tested my normal distribution. So the question number 6 is there. You can see here the data range. All the respondent 27 kilowatt, 32, 18, 35, 8, 32. So you can see here all are in a similar one kind of range. If I put 100 or 102 or 1, that means those numbers are the outliers numbers. Understood? So if there was any number, if there is any number, then it will show here. But here in our case, there is no such outliers. So again, we can say that our data. So hence can be concluded that the question 6, the whatever variable we have calculated is approximately normally distributed. Understood, everyone? And how can you interpret it?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Got it.
Clear?
Thank you very much.
Yes. Okay.
Yes.
Shall I move ahead?
Please.
Yes, ma'am.
Okay. Okay. So now once we finalized our data is normally distributed. Now our data is normally distributed. So which kind of test we use? Parametric test. Okay. If the data is normally distributed, then we use the parametric test. But if not, then the non-parametric test. But here we are assuming that our data is normally distributed. So for our today's session, we are using the non-parametric test. Okay.
Ma'am, one question, ma'am.
Yes.
The thing is that should we employ all the tests like that up to QQ test, or is it up to kurtosis or skewness is okay for?
Yes, it is okay.
If you-
It is okay. It is okay. If you can simply put the mean, median, the skewness, and the kurtosis, then it is okay.
Okay, thank you, ma'am.
Hello.
Ma'am,
Hello.
voice is breaking. It is not audible. It's breaking very often, ma'am.
Okay, so sorry. Just a minute. I can wear the. Maybe I am facing the network issue. Hello. Hello.
Yes, ma'am. You are audible, ma'am.
Yes, ma'am.
Now
You're
audible?
audible.
Yes.
Yes,
ma'am.
you're audible.
Okay. So, am I clear now? Do you get the answers of your questions?
Yes, ma'am.
don't
Yes,
know who
I
has
have
asked.
got your answer.
Yes. So you can again calculate your normality by using simply the mean, median, the skewness, kurtosis, as well as the test of normality. That's it. Okay. Now we are moving towards the next topic, that is non-parametric test. In non-parametric test are again similar to the parametric test. So under it, the first test, the two tests today I am focusing. First is the Mann-Whitney U test. Now, Mann-Whitney U test is the non-parametric alternative to the independent sample T test. So it is a similar of a independent sample T test. The test is used to test for differences between two independent groups of on ordinal data or a non-normal continuous data. So if your data or if your data group has a ordinal data or a not normal continuous data, then you can use and for two independent group. So for two group, you can use this Mann-Whitney U test. Instead of comparing the means of the two groups, as in the case of the T test, the Mann-Whitney U test compares the medians. So in a parametric test, they generally use the mean, but in a non-parametric test, they generally compares the medians. And again, same the criteria, decision criteria. We just we just want to check the p-value. If the p-value is less than 0.05, then we reject the null hypothesis. To understand this, I have taken one example. The problem is to identify if there exists a difference in satisfactions of customer service provided by electricity retailer between the male and female. So I want to check the customer satisfactions which are provided by the electricity retailer. So in same example, I am continuing. So I want to check the satisfaction level between male and female. So whether male and female both are satisfied or is there any difference. So my dependent variable is the ordinal scale, the satisfaction. Okay, and the grouping variable for two group I want to check. So two group is one is the male and second one is the female. So how can I frame the hypothesis? So my null hypothesis is there are no significant differences in satisfaction of customer service provided by electricity retailer between male and female, whereas my alternative hypothesis is there are significant differences in satisfaction of customer service provided by electricity retailer between male and female. So understood the questions, everyone?
Yes, ma'am.
Am I audible? Am I audible? Clearly audible?
Yes, ma'am. Yeah, clear.
Okay, okay. Yes. So how can you run the Mann-Whitney U test? So for that, you have to go to Analyze tab. Under Analyze tab, you can see the non-parametric test. Under it, we have a legacy dialog. Under it, we have a independent samples. So again, we'll understand these example with the help of the SPSS. So this is my question. How satisfied are you with the provision of electricity from your electricity provider? So how satisfied are you with the electricity provider? So the answer is here you can say for one, very unsatisfied. Second is unsatisfied. The third is neutral. Fourth is satisfied. And fifth is the very satisfied. So you can see here it is in order. The scale is in order. You can say that?
Yes, ma'am. Yes. Yeah.
Yes. From very unsatisfied to very satisfied. So it follow a order. So we can call this kind of data or the measurement scale is ordinal scale. So I want to check, this is my dependent variable, the satisfaction. Okay. Now I want to check the satisfaction is depend. So satisfaction can vary between male and female. That I want to check. So for this question number 9, I want to check. So I will go to Analyze tab. Under Analyze tab, you can see the non-parametric test button here. You have to click and the legacy dialog under the two independent sample. So the name was not written here. The name direct Mann-Whitney U test or Kruskal-Wallis test is not written here, but it is a non-parametric test. So it is a two independent sample means it is a Mann-Whitney U test. So whenever you click it, this kind of box will open. Okay, till now it is clear, everyone?
Yes,
Here
ma'am.
you can see, yes, here you can see first one is this test variable. Now test variable is generally our dependent variable for which we want to calculate, and the grouping variable for which group I want to check the result. So here my question, what is my question? Question number 4, 5, 6. So this, for this question, how satisfied are you with the provision of electricity from your electricity provider? So this is my dependent variable. So I will move from here to here. Okay. What is my grouping variable? For which group I want to check? I want to check for gender. So grouping
Male or
variable for
female?
gender. Yes. So there is only two groups. So one is for male and two is for female. So whenever you define your group, then again you have to put the grouping variable. So for that you have to define the group. 1, 2, what is the range of your grouping variable? In a Mann-Whitney U test, it is like simply the independent sample test. So when we have two groups, in that case only we can calculate the Mann-Whitney U test. If we have a more than two group, we can use the Kruskal-Wallis test. So it is always the number of fixed here, 1 and 2, because it is only calculated for a two group. Then continue. The Mann-Whitney is tick here. If you want to here, you are not required to tick anything. Simply press it.
Ma'am,
The option.
sorry, not clearly audible.
Hello.
You are not
Ma'am,
clearly
your
audible.
voice is
My-
breaking, ma'am. Yeah.
Oh, so maybe network is again good network. I don't know why. Now am I audible clearly?
Yes, yes.
Now it's clear, ma'am.
Yes, yes.
Okay. So shall I repeat the steps again?
Kindly, please.
Okay. So how can you calculate the Mann-Whitney U test? So first is for this question, how satisfied are you with this? So again, I am simply removing it. Pin variable. So gender, you have to click here. Now again, when you define your grouping variable, you have to define the groups. Now Mann-Whitney U test is again calculated for only two groups only. It is a like independent simple sample t test. So group 1 is my male and group 2 is my female. So you have to define group here. So this is the simple process. You have to follow same process. Here you have to take Mann-Whitney. It is by default click Mann-Whitney U test. If it is not clicked, then you have to click it. If you want any, it is asymptomatic only. So you have to click options. If you want any descriptive quartile, then you can click. Otherwise, is it okay? Continue, then okay. So this is the result which I am getting. So how satisfied are you with the provision of your electricity from your electricity provider? Okay, and gender, male and female. So this is the first step which I require, and this is the second step which I require for interpreting my result. So I have already copy pasted it in my Word file. So first table, male and female. Okay, and the second one is I have pasted the wrong one. So again, you can copy and paste it. Now, what are the things which I require to check? So first one, in the result of above example, the Z value. So first you have to check this Z value. Okay. So the Z value for hypothesis testing, the Z value, when we can reject the null hypothesis, if our Z value is less than minus 1.96 and the greater than plus 1.96. So if we get those values, then in that case we can reject. Okay. Here, what is the value we are getting? The value we are getting is 0.902. So what is it range? Should it fall in less than minus 1.96 range? 7, which is greater than point S. We fail to reject the null hypothesis. That means we accept the null hypothesis. So what we can say that there are no significant differences in satisfaction of customer service provided by electricity retailer between male and female. So there is no any differences there. If we get the value, suppose assume that if we get the value here 0.23, in that case, what you can write?
We will accept the null hypothesis.
No, we reject the null hypothesis.
No, if the value comes to 0.23,
Yes, then we reject.
It is less than
Yes.
it is less than 0.05, therefore we reject it.
Yes, if the p-value is
95%
less than
level of
0.05, then reject the null and if it is greater than, then we fail to reject. Okay. Here, what value we get? 367. So it is greater than 0.05. That's why we fail to reject. We are not rejecting null hypothesis. Means we are accepting the null hypothesis. So whatever sentence we have made for null hypothesis, we have to simply write interval or a ratio kind of scale. Then in that case, we generally use the parametric test. Though we do not have this scale, but most of the time, many researchers uses parametric test over non-parametric test because the criteria of acceptance is higher in what we can say in majority of the non-parametric. When we apply non-parametric test, then many a time it happened that the null hypothesis would not rejected. So that criteria is higher in a parametric test. So many times you have seen many of the research papers or many dependent variable. So here also you can see there, it is not like only for we can use for ordinal dependent. We can also use for a continuous variable. So it is not always like that. If our data is continuous, then we can only use the parametric. We can use both the test. Means whatever you want to use. So when we use ANOVA, analysis of variance, so it is similar. The Kruskal-Wallis test is similar to ANOVA. So when we have a more than two group, in a gender we have only two group. One is male and second is female. But what happen if we have a criteria like if I want to check for occupation? So for occupation, I have so here in a Mann-Whitney U test, I have checked the satisfaction of customer service provided by electricity retailers between male and female. Now I want to check whether it is whether there are any difference between single, married, or other type of person. So I want to check for marital status. So in a marital status, I have a 3 group. 1 is for single, second is for married, and 3 is for other. So what is my null hypothesis? Null hypothesis is there are no significant differences in satisfaction of customer services provided by electricity retailer among single, married, and other. Or you can simply write among marital status. And my alternative hypothesis is there is a significant difference. How can you check or how can you run the Kruskal-Wallis test? So again, you have to go to analyze tab. Under it, the non-parametric test. legacy dialog, and here you can see the k independent sample. So from this, you can calculate the Kruskal-Wallis test. And my grouping variable is married. Not required to do anything. If you want to copy paste it in your Word file. So here I have a sample data. So first is the rank, the single are 29. This n means the number of the people. Single are 29, married are 33, and other are 17 in our data set. The mean rank is given for that. Here you can see the chi-square value, the degree of freedom. What do you mean by the degree of freedom? Though the value is 0.99, here I have rejected the null hypothesis to show you. Though the value is again not, it is not less than 0.05, it is greater than 0.05. So if it is a greater than 0.5, then we reject the null hypothesis. But to show you, assume that this value is 0.25. So how can you write this? You have to first write down the chi-square. So chi-square, you have to give the chi-square sign. What is your degree of freedom? Your degree of freedom is 2. So what is the chi-square value? 4.630. What is your p-value? 0.099 with a mean rank. With a mean rank of customer satisfaction, the 37.78 for single, 37.02 for married, and 49.59 for other. However, this 49.59 for others. So this is how you can write the interpretation of the Kruskal-Wallis test. So here the p-value is less than 0.05, though it is not, but it is in a range. So that I have rejected the null hypothesis. Understood, everyone?
Yes, ma'am.
Okay. So that's it in today's session. We have seen the normality, Mann-Whitney U-test, and the Kruskal-Wallis test. So Mann-Whitney and Kruskal-Wallis test again are the similar test which we used in a parametric like independent t-test and the ANOVA test. Okay. Tomorrow we'll see on the correlation regression as well as how you can calculate the reliability. So I hope it is clear and you can understand it clearly. Is there any questions?
Ma'am, could we download SPSS for free, or like is there any paid versions for SPSS?
Yeah,
I'm going to try for the first time.
you can download it
Sorry?
for 30 days from IBM statistics website is there. So you can download. Earlier they are giving for 30 days, but I think now they have reduced the time. Whenever your data is ready, so at that time you can download. So it is available. They are providing for 15 days for free.
Oh. Is that learnable very easily, ma'am? Because I'm trying to like explore for the first time.
Okay. So how was your experience?
Today it is like I gained the confidence to explore SPSS, ma'am. It's like with your guidance, like I feel confident.
Thank you so
Thank
much.
you so much. Yeah.
Yeah, thank you. Yes, is there any questions?
Ma'am, it was very much clear to us, and we have enjoyed the journey. Thank you.
Thank you, sir. Thank you so much.
We eagerly look forward for tomorrow's session, ma'am.
Yes, definitely.
Thank you so much, ma'am.
Okay. Yes, thank you. Thank you all participants. So the organizer.
That's my understanding, sir.
Yes, sir. So I think
There are participants.
there are no questions further.
Thank you, ma'am.
Yes,
Okay,
ma'am.
welcome, sir. Yes, participants
Okay,
do not have
thank
any
you, ma'am.
questions.
Thank you.
Yes.
Okay, ma'am. Thank you, ma'am. Tomorrow, we may meet on tomorrow.
Okay, okay. Yes, sir.
Hello, sir. I joined the meeting late due to I missed the link. Means I
Sir, no problem,
forgot
sir.
it. Shall I get the recorded video?
Sure, sir.
Okay. Thank you.
Surely you got it, sir. There is no problem. No problem.
Okay, sir. If I get the recorded video on the documents, is helpful. So before tomorrow meeting, I will look on it and come for tomorrow meeting. Thank you.
Okay, sir. I try to come to the meeting on earlier.
Sure, sir.
But anyway, I will send the recording in our WhatsApp. No problem, sir.
Thank you, sir. Thank you all.
Thank you, participants.